Alright, midterm solutions. This is the green test, problem 1. It's the chapter 2 stuff. We use the difference quotient and the definition of the derivative. I went ahead and wrote that down here just so we'd have it handy, this being the difference quotient here. And what we need to do is find the derivative of this guy. Might not be a bad idea to first use our chapter 3 methods to figure out what this derivative is. And I think the easiest way to do that is to recognize that this right here is 1/2 times x to the negative 1. So if we take the derivative, you can leave the 1/2 alone, and then we got bring the negative 1 down and subtract 1 from the exponent. So another way to write that is negative 1 over 2x squared. So hopefully this will be what we end up getting when we do a bunch of simplification over here. So let's see here. Using the difference quotient, limit as h approaches 0 of our function evaluated at x plus h. So here's our function. Instead of 1 over 2x, we'll write 1 over 2 x plus h minus our function, 1 over 2x. And that is all divided by h. And we can't just plug in h equals 0 now or we'll get 0 over 0. So what we'll have to do is simplify the top a bunch so that an h kind of comes out of it that we can cancel with this h on the bottom. Then we'll be able to plug in. So we'll need a common denominator. Let's see, we have a 2, an x plus h, and an x. So our common denominator will be 2 times x plus h. So we'll need to multiply the left side here by x over x. And multiply this side by x plus h over x plus h. And if you do that, what you end up with is x over here on the left hand side and minus x plus h, careful with the parentheses, all over our common denominator of 2 times x plus h. And that is all divided by this h, which maybe now I'll write as h over 1 to keep my fraction straight. And what's nice about this form is up top we have x minus x plus h, so these two x's will cancel out and we'll be left with negative h. Let's see, the limit as h approaches 0 of negative h divided by 2x times x plus h. Note this is a negative h because we have to distribute this minus sign through. This stays the same. And then if we want to divide a fraction by a fraction, it's like multiplying fractions except you have to flip this guy upside down. So we'll have to multiply this by 1 over h. And what's nice about that is this h right here and this h right here cancel out. And when those h's are gone, we'll be able to just plug in 0 for all of our h's that are left. And what we end up with is negative 1 over 2 times x plus 0. That is 2x squared, which sure enough matches up with what we thought it would be. Moving on to part B, use the definition of the derivative to find the equation of the tangent line to this function at this point. Alright, f of x is given. A is 2. 5x squared minus 9x minus 2. And then here's f of x. We have to subtract f of a. Might be worth figuring out f of 2 over on the side. That's 5 times 2 squared minus 9 times 2 minus 2. Number's getting a little big here. 2 times 2 is 4 times 5 is 20. Minus 9 times 2 is 18. Minus 2. Looks like we end up with a 0 up top. So f of a is 0. Kind of nice. We don't even have to have anything there. So we can't just plug in 2 right away or we'll get 0 over 0. But what we can do is rewrite the top. We know that the x minus 2 is going to cancel, so there must be an x minus 2 up here. So really all we have to do is figure out what the other thing is. It's going to be a linear expression, a first degree polynomial if you want, so that we end up with 5x squared here. We'll have to have a 5x here, so 5x times x equals 5x squared, and a plus 1 over here. Negative 2 times positive 1 is negative 2. The middle term should work out. We could check it if we want. Negative 2 times 5x is negative 10x. X times 1 is positive 1. Negative 10, positive 1 gets us to negative 9. So that gets us down here. And what's nice about this form is now these guys cancel, which allows us to just plug in 2 for x, and we get 5 times 2 plus 1, 10 plus 1, 11. Probably not a bad idea to check that this is right by finding the derivative using our tricks. Let's say using our tricks we know that f prime of x should equal 10x minus 9. So therefore f prime of 2 should be 10 times 2, which is 20, minus 9, which sure enough is 11. But be careful, we're not just done yet. What we figured out is the slope, but this question asks for the equation of the tangent line. So really what we have is our m here. To find the equation of the tangent line, you also need a point. x1, y1. X1 is given to us as 2. Y1 will be f of 2, which we figured out over here is 0. So now if we use the point slope form, we got y minus 0 is just y equals m 11 times x minus x1, which is 2. And if we distribute that 11 through, you get y equals 11x minus 22 for our final answer. And that is the end of question 1.